So I think we can start slowly. Today we are going to introduce you to ABB's and CyanoGuard's combined cyanide monitoring and optimization solution, where we will show you how your mine can maximize your leaching performance. Today's agenda is introduction to trends and technologies in gold mining process control. We will talk about ABB's Ability Expert Optimizer and APC solution for mining. We'll go through a few use cases showing you where mineral processing has been made more profitable with ABB's Ability Expert Optimizer. Show you how CyanoGuard's innovative cyanide technology can help you optimize your cyanide monitoring, how you can achieve increased gold leaching performance by combining CyanoGuard's digital cyanide measurements with ABB's Ability Expert Optimizer. And last part is Q&A session, where you can ask us anything about our combined solution. And in case we didn't manage to cover all of your questions, you can always reach out to us and we'll get back to you. Today's speakers are Ryan Koorts and Neiszer. Ryan is Global Product Manager for ABB's Ability Expert Optimizer, which is ABB's advanced process control solution for the mining industry. And Ryan has a background in chemical engineering with experience in applying APC into mining industry. And Luis is CyanoGuard's business developer with experience in chemical engineering. And Luis also worked within the mining industry, and Ryan is based in Switzerland and Luis in Mexico, but he's often visiting us here in headquarters in Switzerland. So Ryan, you can take over from now and let's start.
Thank you very much, Orca. So why are we here today? As most people in the call are more or less familiar with challenges in mining, it's a harsh environment. So how can you improve operations? By exposing more information whilst acting on this information in a automatic way. So ABB Ability Expert Optimizer and complementing technologies such as CyanoGuard's cyanide monitoring can play a dominant role in driving your bottom line. So an autopilot that frees up operators constantly pushing process constraints whilst looking at opportunities to minimize cost and consumables. So as Borka mentioned, ABB and CyanoGuard are combining technologies to close the loop between monitoring of leaching conditions and the autonomous optimization of processing plants, mainly focused within gold leaching. So on the topic of trends and technologies being applied within minerals processing and mining, more specifically gold, the first example I have here is a greenfield operation, gold fields in Chile. The operation Salares Norte, where ABB Ability's Genix platform for industrial analytics and AI has been deployed with the integrated remote operations center in Santiago. So what we have is the gold mining plants in quite a remote location in Chile, with the electrification and digitalization solutions all integrated, and then the remote monitoring center a few hundred kilometers away in Santiago. So what the Genix suite is facilitating is real-time process optimization insights into process efficiency monitoring, specific energy consumption overview, process behavior predictions, basically optimizing on-site operations, headcount, whilst taking people out of risk areas, leveraging from a pool of specialists to assist with multiple operations. So when you centralize the visibility and overview, you increase the collaboration, removing siloed operations and optimization. So increasing the visibility over the full value chain of the operation, whilst creating the single source of information here within the Genix suite. So the Genix platform is integrating around 25 third-party systems from OT and IT. Like I said, from the complete operation from mine to plant. So the Genix platform is allowing for better decision making on production planning, operations. Some examples would be real-time energy consumption forecasting and improving energy contract accuracy. So that's one example of a technology being applied currently. Another example would be short interval control. And this is more related to brownfield, where short interval control is taking decisions in real time based on personnel and equipment availability and their status, and then reshuffling tasks in an optimum fashion based on live events. So unlike the process plant, digitalization upstream in mining is fairly new or in an infancy type state. So here ABB is collaborating with customers such as Goldfields and South32 on ISO 95 framework with the aim to develop and implement interoperability standards for mine planning, mine scheduling, execution, so that the equipment and applications for mining operations more or less become plug and play. So slowly catching up to the control aspects of the plant. So that's the second example of technologies and trends related to gold mining and processing. I'll talk quickly about some other trends and technologies more related to sensing. So basically, a challenge in mining is measurements. So the ability to connect any new device, giving additional and new insights into how well the processing plant is performing, is critical for any progression towards autonomous mining. Some examples here that I've pulled out, we have image analysis, and this can be either related to understanding particle size distribution around crushing and grinding, or through understanding the characteristics of flotation. So here we have image analysis on flotation, where we work with a partner that exposes frothing characteristics such as bubble size, bubble count, and velocity of your froth. Another example of a partnership would be with MineSense, and they're more focused on XRF technology at the shovel, so understanding ore quality upstream before it reaches the concentrator, as well as belt sensors using XRF to understand, again, ore quality before it enters the mill. And then obviously with CyanoGuard, providing improved accuracy and frequency when it comes to understanding leaching conditions and obviously cyanide leaching qualities and quantities. And then another example in gold mining that's more recent, at least for myself, would be cascade monitoring. Recently deployed on a mine in Sudan, a gold mine. So here, it's helping understand better the conditions happening in the grinding circuits, helping to better answer questions such as, am I operating at maximum grinding efficiency? What are my shoulder and toe conditions, shoulder and toe angles, as well as are my current conditions causing excessive wear within my liners? So with cascade monitoring, we use an off-the-shelf vibration sensor, which exposes the vibration spectrum around the mill shell and then transmits this wirelessly to the receiving base station, which runs some ABB software that converts this vibration data into useful information. And useful information specifically around key milling features, and then exposes this via OPC UA to the process control system for consumption within Expert Optimizer. So it's basically a wireless device that attaches to the mill via magnets. It's very small, small footprint in the plant, measuring the complete spectrum, like I mentioned. So when you compare it to acoustics, such as a microphone, which are only capturing one point, this is more better suited to the complete spectrum of the mill, capturing more points, as well as the amplitude of strikes on liners. It's redundant, so there's 2 nodes per mill, battery powered, so in total around 9 months of continuous usage. And then, like I said, if with additional milling features exposed, you can then perform closed loop optimization with Expert Optimizer on this information. So making sure toe angles are more or less in a much more smaller operating points, reducing steel ball strikes on liners would be one benefit. Okay, so what exactly is ABB Ability Expert Optimizer? So let me quickly go over this. So I like to refer to Expert Optimizer as a toolbox where there's a range of software technologies that allow an engineer to craft the best solution for that particular unit on the plant. Some of the technologies that I've picked out would be Model Predictive Control, or MPC, where MPC is using dynamic models that are obtained empirically from your process data that uses the historical states as well as the current state of the process to predict future values of key variables such as load or concentrate grade, etc. And then how far away these future values are from either targets or constraints. And then the control actions to drive them either closer to the target or closer to an operating constraint. Another technology would be fuzzy logic, which has been around for decades, and this is more rule-based than data-driven. Another tool technology would be the inferential modeling platform, which facilitates soft sensor and inferential models. And this is useful for when you have infrequent values either sampled from a lab or an instrument that is unreliable and is often going offline. So with this, you have the ability to build robust estimation of particular states, such as density or particle size, P80, and do this using machine learning techniques within the IMP platform that uses surrounding online information to have these estimates of, like I said, either density, P80 as examples, and then either have these values consumed again with an Expert Optimizer. So you are optimizing in between receiving a lab update, and those lab updates might be every shift or every 3 or 4 hours. So if you have an online estimation of these states, you can imagine if you're optimizing that within every 30 to 60 seconds, that's more beneficial than once or twice per shift. Then obviously dashboarding of KPIs specific to the performance of Expert Optimizer. So not process KPIs, but more how well the application is being allowed to drive your process to an optimum, and highlighting certain areas that may need attention. So an operator might be abusing the system, so it highlights areas of concern. One example would be constraints of MVs, so making sure that MVs aren't saturated. So if the Expert Optimizer wants to reduce a certain chemical further or maximize throughputs further than the current constraints, it would be allowed to do that. So this is just one example of a soft sensor. This would be NOx. So we have the green being the measured value and the orange being the predicted. So you can imagine if the actual value were to drop offline, we could have an online estimation of that state for continuous use either by operators or by Expert Optimizer. Okay, so as Walker mentioned, I'll mention a few use cases where this technology has been applied and the potential benefits that have been realized. So within mining, ABB's been leveraging APC technology to improve mining operations from mine to port. If we look at underground, ventilation on demand using MPC technology to optimize underground airflows to reduce energy consumption. Within the concentrator, improving grinding operations to maximize throughput, minimize energy consumption. With flotation, maximizing recovery, minimizing reagent dosaging. With thickening, about stabilizing bed mass and underflow density to either downstream leaching or improving water recovery. MPC's even been used in the marine ports industry. So with the piloting systems to help with the collision avoidance, and here MPC is seen as a critical technology for autonomous shipping. Okay, so quickly 2 examples of Expert Optimizer being applied on a concentrator here with a plant in Sweden. Expert Optimizer taking over control of the fresh feed, the addition of water to the mill and sump, managing the speed of the mill, as well as the pump rate out of the sump to manage targets such as the power, load and torque levels, the density, and the cyclone pressures. And by doing so, like I mentioned before, through data-driven models and always looking at opportunities to maximize throughput and stabilize the process, some KPIs were achieved of increasing throughput by around 2.5%, whilst at the same time maximizing mineral liberation by 4.3%, and reducing specific energy by around 10%. Just to mention, I think these use cases are also published on the ABB website if you want to dive deeper, or contact me for more information, because I am going over it very quickly. Another example with flotation applied on a different mine in Sweden. So here, Expert Optimizer taking over control of managing the air level and reagents to always look at opportunities to drive concentrate grade to a lower limit, thereby increasing and maximizing recovery, as well as looking at any opportunities to minimize either xanthates, or I think it was also frother. But overall, by minimizing variability and driving it to a lower limit for the concentrate grade, recovery was increased by just under 2%. And this was a zinc plant. The one before was copper. Okay, so I'll hand over now to Lewis to give a brief overview of CyanoGuard's leaching technology.
Thank you very much, Ryan. So we've talked about the importance of data, but it's also worth mentioning that this data needs to be reliable. So here's where us, as CyanoGuards, provide reliable cyanide analysis for both free and wet cyanide, and at the same time, we provide digitalization of this data. That is the first step to properly manage and optimize your plant. So first, I want to explain a little bit why are we, as a technology company, focusing in having a reliable analysis for cyanide. So cyanide is the most cost-effective solution today to leach gold from ore, even that cyanide has been used in the mining industry for more than a century. Well, cyanide represents the highest consumable cost at the processing plants. In average, represents 6% of the total cost, or cash cost, as some of you know this parameter, but it can go as high as 20% in some specific cases. Also, cyanide has a direct influence in the metal recovery and plant performance. So accurate measurement represents an important opportunity for gold mines to optimize its plant. Because traditional methods, as silver nitrate titration or potential geometric analysis, are not that reliable and have significant interferences with complex ore. This leads to underdosing or overdosing of cyanide in the leaching circuit. The estimation is that more than $30 billion worth of gold are lost every year due to a lack of proper reliable process control and optimization technology. The next one, please. So how do we do that, right? We have a patented solution that is unique in the market. Why? It's reliable. It shows no interferences, as our chemosensor has a high affinity and selectivity for cyanide. It doesn't have any interferences with other elements such as copper, silver, zinc, hypersaline matrices, thiosulfates, and thiocyanates. It's fast. The solution procedure is performed in less than 2 minutes, and the results for both free and wet cyanide are shown in less than 30 seconds. And last but not least, it's simple. The procedure is not complicated at all. It's basically flushing the solution you want to analyze to our cartridges. And once the sample is analyzed, the analyzer transmits the data in real time to our cloud platform. If needed, this data can be integrated into the current process control systems. Our benefits have shown up to 15% of reduction in cyanide consumption and up to 20% reduction in cyanide associated costs that include detox reagent costs and pH control costs. So back to you, Ryan.
Thanks, Lewis. Okay, so I'll go over now some high-level design of how we are marrying these two technologies. Okay, so what we have here is the overview. So how do I explain? So at a higher frequency, what you have is Expert Optimizer on plants, consuming information from the pre-leach thickener, such as the thickener underflow density, bed level, bed mass, torque turbidity. And this is, like I said, at a high frequency, so every 30 to 60 seconds. And then understanding where these values are in relation to where they should be, and then taking corrective action through the data-driven models, which understands the long-term dynamics, which are typical of thickeners, taking corrective actions on managing the thickener underflow pump, the flocculant dosing, and the management of water. And then at a different frequency, so a little bit slower, what you have is Expert Optimizer consuming information from the CyanoGuard cloud platform relating to the current cyanide dosing level. And again, how far away this is from the target, as well as pH levels. And then again, making corrective actions by managing the dosing of cyanide and the dosing of lime to minimize this delta from target. So yeah, basically quite a large scope in terms of optimizing upstream units such as the thickener and managing all leaching tanks when it comes to the cyanide dosing and lime addition. And in addition to this, also the possibility to include infrequent lab assay results, which are relating to the extractive gold recovery, and then whether it makes sense to increase the profile of either the cyanide targets, the pH targets, or possibly the density target coming from the upstream pre-leach thickener. So the benefits you can expect from combining these two technologies, one, as I mentioned, reducing variability around your dosaging and actual measured cyanide. So you're constantly running more closely to targets. So as an example here in black, the estimates with control are running more closely to the target of 250 ppm of a free cyanide. And then by increasing the scope of what actually influences extractive recovery, like I mentioned, managing also the pre-leach thickener. So here we talk about, again, reducing variability of what's leaving the thickener, so reducing the variability around density, and then shifting this density closer to where it should be. And also the minor benefit of reducing any overdosing of flocculant, so looking at opportunities to minimize cost within the pre-leach thickener. And also by minimizing variability in the bed mass and minimizing any violations of torque with the rake, you also have the possibility to reduce wear related to equipment. So in overall, this has a positive improvements on your operating bottom line by lowering cost and improving the yield. So if we look at typical experience with closed loop optimization related to reducing consumables, this is normally in the range of 5 to 20%. So if we look at a typical reference for a gold mine of 1.87 tons per day of cyanide consumption, at our current daily prices, this is anywhere between $100,000 and $370,000 per year. And if we look at the benefit of increasing yield, so talking about increasing gold recovery, because we're stabilizing conditions not only in leaching, so operating more closely to your target and where you want to be, but by also improving upstream units, such as the pre-leach thickener, it gives the leaching tanks more opportunity to improve the gold extracted and leached, so improving gold recovery. And by operating in a closed loop manner, you also have the soft benefits that are often overlooked with these types of programs and solutions. So here, freeing up operators to not focus so much on the minute-to-minute or hour-to-hour control of leaching and thickening, so allowing them to focus on different parts of the plant. So basically freeing up operators. So that's more or less from me. So I hand over now to Borka.
Thank you, Ryan and Luis, for a great presentation. And now we will start with the Q&A session. I would say maybe the most important part, where you can submit all of your questions. And Ryan and Luis are going to first go through the questions you already submitted through the registration form. So yeah, and feel free, please send your questions in the Q&A section. Thank you.
Okay, so I suggest, Luis, I take the first one, and then
Sure.
we go down, and then. Okay, so the first question: Can this program or system be used on other control systems? So the answer is yes. It doesn't have to be an ABB DCS. Quite a lot of our projects are done with third-party control systems, so that's quite a common project setup. So there's no issue there. Where obviously the communication to the process control network is DA or UA with OPC. I guess the next one is for you, Luis.
Yeah. Is there a standard method to validate results obtained from CyanoGuard's kit, and how often should it be done? So basically, we have the ability, or we suggest sending the sample we are analyzing to a third-party laboratory, so the user is comfortable using our solution, and it validates the results we show. How often should it be done? We don't have like a time frame, but it can be done as often as the user wants.
How do you reduce consumption? I can talk from the EO perspective, and maybe if you want to complement later, Luis.
Yes.
When you set up the application, you can define the objective function of what Expert Optimizer is targeting with the control. So, for example, reducing consumption can either be by stabilizing the process. As an operator, you can then dose less, or if you include the dose and control with Expert Optimizer, you can simply set the objective function to always look at opportunities to drive that particular reagent or cyanide or lime down when there's opportunity. So that's how you reduce consumption of consumables.
Right, and I think here, apart from being closer to the objective target value of cyanide, the other big part here is traditional methods for free cyanide have a lot of interferences with metals in the solution. As I said before, our patented solution shows no interferences, so the result that is showing is real. Because with the traditional methods, the results are higher than reality. So this can lead to overdosing of cyanide solution.
Expert Optimizer communicates to the CyanoGuard Platinum via a REST API, but here I'm not the expert. So if this is really important to you, please reach out to me and we can talk with our architect experts to explain that better. Okay, this one's for you, Luis.
Yeah, are there any new technologies and/or simpler and safer protocols for cyanide management? Yes, here I will talk about a specific case use we have. So we have a user that wanted to measure watt cyanide in a faster and simpler way. The current watt cyanide analysis, one of them is performed with picric acid. The picric acid procedure takes a lot of time, and also one of the reagents used is explosive, basically. So with our solution, we use that risk. They don't have to use this method anymore. Basically, with the same cartridges, you can measure also watt cyanide. So talking on our side, with our solution, we also make it simpler and safer for cyanide management and analysis.
How do you achieve higher gold yield using your solution? From an expert optimizer perspective, again, it's about stabilizing the process, and then you can shift it closer to targets more consistently, improving extractive recovery and leaching. That's from my side. I don't know if you want to add to that, Lewis.
Yeah, on our side is basically if you're not, if you have a process that it's has a lot of variability, in the case you're not overdosing cyanide, you can be underdosing cyanide. So in this case, if your operation is quite large and you don't have the ability to have cyanide analysis results fast, you could be losing gold into the tailings, right?
Yep.
Tank leaching.
How do you develop the models? The models for the application are data-driven, so state space identification is a tool commonly used, and that really allows you to understand the dynamics of the process. Reach out to me and I can go over that with you if that's of interest. Next one, Lewis.
Yeah, what range of cyanide, in this case free content, is within the normal ability of the analyzer, minimum and maximum? So we can analyze from 0.1 parts per million to 4,000 parts per million of free cyanide. That's kind of our standard, and it should cover all of the analysis performed at the plant. But we can go higher if needed on request. But of free cyanide, 0.1 parts per million to 4,000 parts per million.
Okay, the last two are yours, Lewis.
Yeah. Do you make site visits to major users to make sure they are using it correctly? Yeah. So we like to visit our users not only to train them in our solution. As I've said, the method is quite simple, but also to go through all of the cyanide analysis associated, activities, sample preservation. How are you analyzing the solution currently? Why is our solution better? Train the operators, explain them a little bit about how our solution works. So yeah, we make site visits. We like to make site visits to our users, not only in the beginning, but also like on a regular basis. And the last one, would it be possible to test what cyanide? Yes, we recently finished with the developing of what cyanide, and we can also test what cyanide with our solution. The ranges are the same, 0.1 parts per million of what cyanide to 4,000 parts per million of what cyanide. Yeah, so I think we finished with the questions that were submitted beforehand. We have one question on the chat. What is the technology behind CyanoGuard? I will take this. So basically, our solution works with this orange thing that is our chemosensor. The chemosensor is based out of vitamin B12, that it has high selectivity, high affinity to cyanide. And just repeating that again, that is a quite unique solution in the market because it shows no interferences with other methods in the solution. So basically, the chemosensor does the analysis, it changes color, and the change of color is analyzed by our mobile analyzer. So overall, this is how the technology behind CyanoGuard works. So I don't see any other questions in the chat.
If you have any more questions, feel free to ask them now. In case you missed something, you can always reach out to Ryan, Lewis, or even to me, and we'll get back to you.
Sure.
Good.
Thank you very much, Ryan.
Yep.
Thank you very much, Borka, and all of the attendees today.